I know that it does, but let's just see. X, I'm going to do minus 4 just for something different. And graph that. And minus 4, x minus 4, all inside the absolute value, has made it move to the right by 4. Okay? How do you think we should turn this thing upside down? Negative. All right, so let's try that. Now what we're going to do is we're going to put that negative in a particular place. So I'm going to put that negative out front of the absolute value. And then I'll put in the absolute value of x. Close my parentheses, and hopefully I'll have something that's upside down. Yeah, it makes a nice picture too. I did negative absolute value x. You can always see my commands up here if you look at the little boxes. Okay? Two more translations to go. And then we'll put it all together. All right, I'm going to put a 4. I'm going to do y equals absolute value of 4. I'm saying y equals 4 times the absolute value of x. Any guesses what it's going to do? Yeah, it's going to make a V. Good concept. What did it do? It got skinny. It got narrow. That's called a vertical stretch. It got skinny. Okay? Yes. Vertical stretch is when it's getting stretched up on the vertical axis, and in other words, it's making it skinny. We'd also like to make it wide. Any guesses for how we could make it wide? Multiply by a negative. Let's go. Oops. What did I do there? Y equals. Okay. Second. Insert. Negative. So, negative 4. It just did the vertical stretch upside down. Interesting. So my last thing I got to do is figure out how to make this wide. All right, I'm going to put my fraction in. How about 1/2? There's a fraction. So I'm going to put it in 0.5. You go to the right of where you want to insert, and then you hit second delete, and you insert. Okay? What did putting 1/2 do? Made it wider. That's called a horizontal stretch. Fractions between 0 and 1, actually fractions between -1 and 1, make it wide when you multiply it before the absolute value. We're not going to put that stretch inside the absolute value like the ones we did yesterday because that was a pain. It's called a horizontal stretch. Okay, so let's see where we're going here. We've done all these little graphs. Okay, so the format for the absolute value function is not going to look like we did yesterday. It is y equals a times the absolute value of x with no coefficient here minus h, close the absolute value, plus k. And that is going to be a translation, or actually a transformation, of y equals absolute value of x, which is the parent function, where hk is the new vertex. So I'll grab the vertex off here, hk. We translate right if h is positive, left if h is negative. We translate up if k is positive, down if k is negative. And the slope is represented by that letter A. So the slope of the right side of the V is going to be that letter A, and the slope of the left side of the V is going to be the opposite of A. Okay, so let's put that into a little bit of action here. Do them one at a time. Again, do we need to know which? Yeah, but it may. So the most important bullet points to write down, I would think, are where the vertex is, and that the slope is A. And then the other two, the left, right, and the up and up, down. Maybe that'll be better by example, because we have just done those. Well, we'll talk about that. We'll graph one. I'll show you what that means. It's going to be better to look at an example, I think, than in the words. Waiting. I know. I was going to push the button. I'm waiting. All right. We ready? Yes. Good enough. Okay. Y equals absolute value of x minus 2. What does that do to the original absolute value of x graph? That is a down 2 translation. So what does that one look like? Well, that is the absolute value of x minus nothing, minus 2. So my h is 0, my k is negative 2. So my vertex is at 0, negative 2. My slope, the A number, there's no number here to the left of the absolute value, so my slope is 1. So that means the slope on the right is 1, up 1, right 1, boom. Slope on the left is negative 1, which is up 1, left 1, boom. Okay. Onward. If I have y equals absolute value of x plus 4, that's y equals absolute value of x plus 4 plus 0. So my h is 4, my k is 0, which means my vertex is at 4, 0. Oops, my h is negative 4, sorry. It's the inverse, yes. This actually is, let me go backwards a little bit here. Absolute value, oops, backwards one more. This is the absolute value of x minus negative 4 plus 0. My h is negative 4, my k is 0. My vertex is at negative 4, 0. They kind of go in the opposite order. So this was x plus 4, so my vertex is negative 4.